Hi, welcome back. So we are at a new episode from the playlist tutorial program with C programming language. In this episode, we are going to have a quick overview on some key concepts in C programming language. First, we'll be looking at keywords and identifiers, as well as variables and constants, and C data types, input and output, comments, and operators. Finally, we'll be looking at a lab example to recheck all these concepts that we are going to learn about in abstract point of view. Let's go ahead and explore the first outline, that is keywords and identifiers. Now, before I walk you through the meaning of keywords and identifiers in C programming language, I would like to draw your attention that all the alphabet in C programming language, either in uppercase or lowercase from A to Z, are at your disposals. In addition to that, all the digits from 0 to 9 and some characters such as comma, open bracket, percent, etc. Now let's check the meaning actually of keywords, and then we can have quick understanding on the meaning of identifiers. Keywords indicate or implies that those words have been reserved by C programming language. In other words, if you are writing a code and you attempt to use one of these keywords as, for example, kind of identifier or variable, then the compiler will throw an error. So you have to make sure that you don't really use any of these keywords because they are already reserved, and the compiler recognizes them as a reserved word with a specific meaning using C programming language. For example, auto or brake or case or car or char, continue, all these are actually reserved keywords in C programming language. Now, what does identifier then mean? Well, basically, identifier is what you would like to dedicate a specific name to, recall back to it whenever you want. For example, here I would have to choose the word of DAHMAN'S Phi. Now, I could assign this DAHMAN'S Phi. This is called an identifier. I would assign it to have a value of integer, character, or any data type, which we're going to check on them in a while. To this end, identifiers are your choice, but keywords are reserved words by C programming language. Now, there are some tips maybe you want to be aware of while you are choosing your identifier. You have all the freedom to choose whatever you want, but choosing a valid identifier can be specified using any of these letters that I have shared with you in the previous slides, as well as any of the digits. And of course, underscore as well could be a special character you could add to your identifiers. Next tip, maybe you need to make sure that the first letter of an identifier should be either a letter or an underscore. You cannot start with digit. If you do, I don't think so the compiler will throw an error, but it is not really a good practice from production perspective. Last but not least, you need to make sure that you choose a meaningful kind of identifier, a specific name that have a meaning that you know you want to get back to it. But also you need to consider the length of that identifier. Now, most likely you will not face a problem, but I think in some kind of compilers, they might throw an error if your identifiers exceed 31 characters. Now, the next thing we want to check about is the meaning of variable, constants, and escape sequence. Now, when it comes to variables, that means any of the identifiers you would like to choose, you can assign it to a specific data type. For example, here I am choosing identifier with the name DAHMAN'S Phi, and I have decided that any value DAHMAN'S Phi would take can be of type characters. Now, the way I could do that, just like you see on the screen, car and then or char, and then you can define the identifier as DAHMAN'S Phi. And then after that, you could assign the value of character that you would like to do. This is right, and there is no problem with that. The compiler will not throw any error. Alternative to that, you might choose to, on the same line, assign also the value of the identifier. In this case, for example, we have again the DAHMAN'S Phi as an identifier of type character, and I am assigning letter A to it. Later on, throughout the life cycle of the application, maybe I have decided to assign a new value to DAHMAN'S Phi. That also is a legitimate thing to do. There is no problem at all. However, if I would have to attempt to try to assign any different type rather than the one I have initiated, then the compiler will throw an error. In this case, for example, DAHMAN'S Phi is recognizing the initiation as a character. So the compiler expects to assign a character to it. However, if I try to assign other type like an integer or digit, then the compiler will throw an error. And by the way, what does variable mean in the first place? Variables means you could say that I have the complete freedom to assign a value to DAHMAN'S Phi, and then later on in the program I can reassign it again. That's why in some cases you don't want to do that. Maybe you want the value throughout the application lifecycle to be constant, and that's exactly the meaning of constant. So the exact definition, as you can see the screen, nothing changed. I choose DAHMAN'S Phi as my identifier that is going to be of type character, and I assign letter A to it, but I want this to be constant throughout the application. So in any case I attempt to assign a new value to DAHMAN'S Phi, then the compiler will throw an error because it's of type constant. Last but not least, we need to check some type of escape sequence. So we have number of escape sequence here. For example, any of those escape sequences start with a backslash and then follow that with a letter or special character. In the first case, for example, we have a case of escape sequence called \B. It's called the backspace. And what does the backspace mean exactly? Let me show you an example of a print F function here. In this example, I am printing a sentence called test example. So if I would have to write test and then example, and between them there is this space, and then I assign this backspace escape sequence. Of course, the /n means a new line. That means whatever you write, and then the cursor will start a new line automatically. Now, if I print that, the result will be test example, and then the space will be deleted. The reason because of this backspace usage. Now, there are some cases you need to do that, but this is available kind of escape sequence. The second one called the form feed type of escape sequence. Now, in an example of the Fibonacci series number we've seen before, in the output we saw the first 10 numbers or so from the sequence, and you could see that the escape line of them, there was just a new line. But if I would have to use actually the form feed while I'm printing, that means that between every new value printed on the screen will be a new line added. Next one, it's the new line. We have seen the meaning of that. Then you have something called return. And return is very interesting actually in many different applications. Let me show you an example. If you would have to print test example of a certain digit, and then you assign it to value of 0, and then again you print a new line, and after that you print test example, again a new digit of 1. Now the result of that, if you print in the screen, will be just as expected, test example 0, a new line, and then test example 1. However, if I would have to replace this \n, which is a new line, with r, that means return, what will happen here? First, you will have to print test example 0, and then the compiler will delete that line and then get back to the beginning and print on top of that a new sentence, which is test example 1. So the result would looks like exactly this, whereby you could see first they printed test example 0 and then deleted and get back the cursor to the beginning of the line and print test example 1. Maybe this example can be practical while you are designing some kind of application, printing something on the screen. So instead of flooding the screen with so many lines, basically you print the line and then you delete, get back cursor to the beginning and print the new line, and so on and so forth. So you will just be occupying the first line on the screen. You could see then you have horizontal tab, vertical tab, backslash, etc. The rest of these escape sequence are self-explanatory. But the last one, maybe I need just to highlight, called the null character, which is \0. Now, this one we will be visiting sometimes later when we speak about strings. And this kind of escape sequence is very important for the compiler because it recognizes this is the end of a certain line. Now, the next thing we need to discuss about actually related to data type in C programming language. I think the concept of data type is almost like any other programming language. So, for example, you have an integer type, character type, or char is called float, double, short, integer, etc. Now, the important thing, as we have discussed, C is a compiled kind of language. So it gets us so close to the physical machine. So we are almost in control of the physical memory on that machine. That's why we are very much careful of choosing different type based on the size that will be assigned in the memory. For example, if I would have to choose an identifier of type integer, I would have to understand that there are 4 bytes are located on the physical memory on that device. Now, the exact details of this allocation of 4 bytes and what does that mean, that will be maybe in the next episode when we discuss some technical tips. But for now, we should understand that data type of integer, that means there are 4 bytes will be reserved in physical memory. The next thing you need to know is something called the format specifiers. Now, so format specifiers, it tells the compiler with this format of % and then a letter indicate what kind of actual data type I'm talking about or I intend to print on the screen. So if I would have to write %d or I'm telling the compiler I would like to retrieve a value of integer whatsoever the output I intend to have. A character, for example, it have a size of 1 byte and the format specifier for that C, and so on and so forth. But before we leave this kind of data type, which is easy to read on your own, I'd like just to specify the meaning of this signed and unsigned, either integer or character. Now, signed implies that the number could be positive or negative. Unsigned means the number only can be positive. Now, if we are talking about integer, it's possible to have signed or unsigned type of integer. However, what does really mean to have a character, signed or unsigned? This is where I want you to know that when we speak about unsigned character, we implies a range from 0 to 0xFF and hexadecimal kind of counting. And when we speak about signed character, we implies a range from 0x80 to 0x7F, again in hexadecimal number. And those ranges actually translate from 0 to 255 decimal and from -12.8 to +27 decimal type. Now, you could see that characters in this case are actually occupying 1 byte, but the representation of that character is going to be in a hexadecimal type. And then I could decide based on signed or unsigned kind of hexadecimal and based on that range. The next thing we're going to talk about is the input and the output. And this is the most important and primitive concept of system and engineering. Input, process, and output. So we expect actually the entire application have a purpose. So you expect an input from the user and then you do process and then you output something on the screen. So the inputs come from where? It could come from different types. For example, if the user is on a keyboard button, the user is clicking on that keyboard, it's considered an input. The mouse motion, click on the mouse is an input. The mic is an input, etc. So these are different type of input you can expect. Now in C programming language, the most primitive and basic one, you expect the user to enter a certain value using a keyboard. And now in this example, you see in the screen, I'm using a specific function called scanf. There are alternative as well, but let's assume that I'm using this built-in function from C programming language called scanf. And the format for that, you call the function and then you call specific specifiers, which we have discussed earlier. And you can see them down there in the screen, different type of format specifier. So you choose one of those specifiers. That means you expect the user to enter a specific value within that type of specifier. So if I would have to write %D, I expect the user to enter a digit. If %C, I expect him to enter a character, etc. And then we have this comma, and after that you could see the ampersand, and then I call on the name of the identifier. Now the ampersand and the meaning of input or the identifier will be explained in the following sessions, but for now this is the format in general while we're dealing with input. Output is what you want to print on the screen. Now this is the most primitive one of using printf function. Again, you are actually calling specific specifiers to be printed. So if you call specifier to be in a form of a digit, then the output formatted will be a digit form, maybe in a character form, maybe in a pointer form, etc. And then, of course, you're going to decide on the name of the identifiers. Next one we're going to talk about is the operators in C programming language. The first type of operators, the most basic one, is the arithmetic one. So we have the basic for operators of addition, subtraction, multiplication, divisions. And also we have the modules division one, which actually carry the remainder after division. And then we have the next one called the increment and decrement type of operators. Let's say this a small piece of code actually implies the meaning of increment. So in the first line here, I am actually defining two different variables or identifiers. You could call any of these names A and B, and I am assigning values to them, a value of 10 and 100. And then in the second line, I am calling or identifying two more different variables, which are C and D of type float. And then I'm calling the print function, and I'm saying, well, I want to print this string of ++a equal. Now then I'm calling the specifier. I want to print type of a digit. And after that, of course, I'm calling the character sequence of a new line. And then I call the ++a, which is actually 10 and incremented by value of 1. Same thing for the second line, where I call the variable b, and I am decrementing its value by 1. And then the same thing happens for the float c and the float of d. You expect the output exactly as you could see here on the screen. The next type of operators called assignment. So you get like equal operators. The example is just very explanatory. So these are shortcut. I think most of the new type of programming language offer you this kind of simple type of using operators instead of writing actually explicit meaning of it. But you have to be careful and you practice them anyway. The next type of operators called relational type of operators. Greater, less than, not equal to, greater than, equal, or less than and equal. So the next type of operators called logical ones. And the use of them is exactly as you could see in the screen with some examples. Next type of operators called the bitwise operators, which are actually a single type of operators, as the ampersand or, and then you got the bitwise exclusive or complement, shift left and shift right. Now, these kind of operators actually, most likely you're going to deal with them while we are different type of workflow with C programming language. Just keep aware of them. Now, last but not least, we have to come now to a lab where we can actually pick all these abstract meaning of overview on these keywords, variables, and characters, etc., and put them in a practical example. Now, before I show you the number of tasks we're going to be accomplishing, let's go ahead and actually open our code blocks and create our first lab setup environment. Now, I'm here on the code blocks, and as you start the application, you have different options. First of all, you could directly go to create a new project or open an existing one. Either I could come to this, create a new project, or maybe also from file, new, or I create a new project from here. So let's create a new project. And you could see here we have really different number of project, bunch of them. Most of them I didn't use. I just used some of them. For example, I could work on a type of project like Arduino kind of a project. Of course, console project, which is going to be working in a while. I worked on GTK type of project. Qt5, I did not use actually code blocks for that. but you could also create a Qt project. You have different type of project. You might want to check them on your own in the future, or see what kind of project you have the ability to create. So for now, in this tutorial, our purpose is to understand C. So most likely we'll be working with console type of project. So if I choose that, I would click go. Next, you could choose either C or C++. Of course, we're going to be using C. And then next, and here is asking what is the project title or the actual name. And then will be translated automatically to the file name. So let's just start, first of all, say this is going to be our lab 01. This is where we're going to work. Next thing I like to do is to actually organize all the work in a specific folder. I don't know your style, but this is the way I like to work. So in this case, I'm going to store in the lab folder. And then I will select that folder as it is and click next. And here we go. The compiler. As we said in the very beginning when we did the setup environment, the code blocks already detected the type of compiler I have, which is of type GCC. The rest I would leave as they are. I'm not going to change anything. So let's create here, finish. And as I am done, you could see here in the management side on this screen, you could have to open the lab, the sources, and the main.c. Now this main.c is the file that where we're going to write our code. All right. Now you could see that there is a form. It's been already generated by default whenever you create any new project with code block. Now you can change the actual creation of such format as you like using the setting, and then you go to editor actually, or environment, any of these. Actually a lot of details if you want to check the documentation. But to keep things simple, I'm interested just to show you the actual basic things here. Now basically here have these two include sentences, std input and the std library headers. Now the meaning of headers at the first place, or what kind of files are there, and what does actually include mean, we will be in a complete understanding as we go through the tutorial. But for now, I want you to know that these are default and basic type of libraries. They also base on number of functions and methods had been already created by others, and they are made available for us that we can, instead of writing the function again from the very beginning, we can just use them. In fact, if you look at the screen with printf, now printf is a method or a function which is actually a member of this inside the std input header here. So you could see I have access to this function because I have called this. So if we would have to remove this, then I will run into a compile error that the compiler cannot understand what does printf means. But now, since I have defined or I included the std input header, then I'm able to use this function. And then we have this, what's it called, main function. Now the main function is mandatory to be there in any type of application, regardless its complexity. The first thing you need to see how to read this particular style. Basically, in C programming language, usually we start with the type of function we're talking about. So this function will return for me a type of integer anyway. You could also have different type, not only integer, which we're going to discuss in the future, but for now, most likely in a default, you will always have the main to return kind of integer. That's why we say we're returning 0. So this is our first like kind of function. You could think about it just to print hello world. Now the syntax of writing here hello world, you should be now familiar with it. This is the printf calling function, open brackets, and then you have the semicolon here, and then you have the double quote of hello world, whatever string you like, and then you have this \n to create a new line afterward. Last but not least, I want to draw your attention, this is unlike Python. I face sometimes problem to forget actually the semicolon at every end of a line of a code. So you have to be careful. At every line you need to end up with a semicolon. This is how the compiler understands the code or compile. Now everything is ready and we are about to start actually the tasks that we should be employing. Now I have decided to do something quite a bit interesting, that instead of actually writing every task inside the main function, why don't we actually create here a complete new function, and then we can just call it down in the main function. Now, this is a kind of much ahead of us, which we shall be understanding in details in the future, but I just wanted to prepare you for much more methodical way of writing code. So in the first task, we need to print a sentence. This is the simplest task you could think of. In this case, it's actually create here a function before the main function. Now, why we are writing before, not after, will be explained in the technical aspect of actually C programming language, how it works under the hood. Now, let's actually define just kind of a void type. For now, what does that mean will be clear in the future. I would say, for example, just we say print function, and that's all, nothing special. And then we need to define these two brackets to start the function. I will say, well, I want to print this simple sentence. This is my first line. And of course, I'm going to start a new line here. And at the end, we don't want to forget the actual semicolon. Now, we would have to want to finish my code. As we said, we need to pass this to the compiler. Now, code blocks take the headache for us. Instead of writing that on the terminal by compiling this file, I mean the main C compiled with the GCC, we just could have come to the code blocks here. We could have the options on running or build and run. So build means actually compile this into the binary format as well as the object format. We will discuss this in detail. Not only the running output, but it will create two different files as well. But for now, let's just run here and build. And as you can see in the screen here in terminal, we got nothing because actually the main function here, it does nothing. In the previous line was like printing hello world, but we deleted that. So let's actually quit and go back to the main function here once again. And let's now call this print function that we have just defined out there. So if we say print function here, and that's all, we're calling the print function. So something will happen now. Let's try to print that. And as we expected is to see this is my first line, but not actually from the main function, but happens to be from the print function that we called just now. Let's go and check what is our next task. Now, the next task, we were asked to print an integer entered by the user. Now, in this case, we are going to be relying on the function called the scanf, which we have discussed in the abstract in previous slides. Now, basically, I'm going to create again a new function here. Well, it does everything for me. It's called just the void type. What does that mean? We're going to learn in the future. So basically, we say here, well, we need to print input. That's it. So what we want to do, we want to accept or take an input from the user, and then we print it out on the screen. But the point here, if I would have to directly go and say, well, I want to use a scanf. And by the way, I am able to see scanf or scanf as two functions here because I'm calling the std input header that you can see in the very beginning here. That's why we usually call the header at the very beginning. Anyway, so if I would have to call this scanf and then I start using the exact syntax we discussed in the previous slides, I will run into an error because we said we need to assign whatever entered by the user to some kind of variable. First of all, let's say, for example, I would like to define what kind of input I want to receive. As we said, to do that, we need to call a specific specifier of type digit. So I expect the user to enter digit number for me. And then after that, I would have to write comma. And then here, what I need to assign whatever the user have entered to a specific identifiers, where we say we're going to use the ampersand call number, for example. But the problem here, we don't have number. I mean, we did not. That's why first we should have actually identify type of integer to be calling number. Now, number here is called the identifier. In this case, I'm not calling something foreign. And at the end, after I finish, I'm able now to take that kind of input and just print on the screen. So in this case, you could say, for example, you entered this specific value. Let's say here now I want to print whatever the value of number is. Again, I want the form of digit, right? I can again create a new line in case the enter will be more than 1. And then here I could call the value of that number. That's it. And then, of course, we don't want to forget the semicolon. Now, if I would have to run this function again, you could see that this is my first line because in the main function, I'm still calling the print function. But what we want actually is to call the print input function. So to this end, let's highlight this one. Instead of deleting that, let's just leave it as a comment. So the compiler will pass this line, will not deal with it. Now we could call the print input function, and that's it. Let's try to run now and see what will happen. As you could expect here, we see that we've done a mistake. What was the mistake? That we did not have any message to the user. Cursor actually expect me to enter something. I would have to enter 5 here. I say you enter 5, so I'm following exactly the exact same details like you could see in the function here. First of all, the actual sequence of the program, it created a number identifier with type integer, and then it went to the next line of scanning F, expecting an entry from the user of type digit, but we did not inform the user with any message. And then we entered this message, you entered number 5. Now here what we could do, we could actually call print function one more time, and this time we're going to actually print this message on the screen, which we call the user to enter something. That the user actually prompt by entering a certain number. So if you enter 5 exactly as expected, you have entered number 5. Let's go to the next task, and that is to add 2 integers entered by the user. Now you should be quite a bit familiar with the syntax, so we can create again a new function here. It's called a void function, and let's call it add a function. And then here in this case, we need to create a strategy, which doesn't have to be too much actually complicated. So we need to enter a line here. We say printf, please enter first number. And then after that, of course, we go into a prompt to call the scanf. Now in the scanf, what I'm doing wrong here, as we discussed in the previous line, I'm going to assign that to a certain digit. So I expect the user to enter digit. However, there's a problem here that I should actually, first of all, defining or initializing my identifiers. That's why I say the strategy of writing code, you have to actually have a kind of a systematic and methodical way of writing code. So first you have to know how many identifiers you're looking for. In this case, for example, I would have all of them of type integer. Let's call them A, B, and also C. Why I call these 3 type of integers? It's basically obvious. A will be my first number, B second number, and C will be the sum. Anyway, you could call C as a sum, whatever you like. So once again, if I would have to run down here, I would have, I'm scanning, I'm expecting from the user to enter a value, and I'm going to assign that value using the ampersand to identifier A. Same line actually is going to be, again, assign that to B. Done. Say C is equal A plus B. So let's try actually to run this, but we don't want to forget to call that in the main function. To this end, we need to call back here the add function actually that we have just created. Let's try to run this and see what the result looks like. So here it says enter your first number. Let's say that's going to be 5. Second number is 5. As expected, the result is 10. Good. But actually, what I want to show you something that I could have, instead of actually assigning or creating even a new identifier called C, completely in the memory, I could actually run this on the fly. And then the compiler would take care by just assigning a hexadecimal type of name to this new kind of variable I'm creating. It's going to be A plus B directly here. Let's try to do that and comment that line, see what happened. So once again, I'm going through the exact sequence of entering 5, 5, and exactly the same result as expected. The only difference, actually printing directly on the fly on a temporary type of variable name the compiler assigned to the operation of A plus B. Now, next task, we are asked to multiply 2 floating numbers together. Now, in this case, let's go and write a new function here. And let's call it actually, as the name is implying, void a float function. And same thing, we're trying to multiply 2 digits. So I could have say, well, if a float number A and B. All right. Now I could have to hold the result as I have done here in the example of A multiplied by B, or I could actually also rely that on a specific identifier. I have the options to do so. In either case, we could do that, but we need actually to keep using that kind of identifier. So let's call it, for example, C again. The same exact details, nothing special, is to ask the 2 numbers. So first, I'm asking to enter the first number, which is going to be assigned to value of A. And then I'm going to ask to enter the second number assigned to the identifier B. And we don't want to dismiss the fact of kind of a specifier of type float. Finally, of course, we need to print now the result. And then we could see the result, what it looks like. Let's try to actually print C here and see what the result like. And we don't want to forget, once again, this is going to be actually comment function, and then we were going to call the new function, and let's call the float function that we have just defined here. Let's run this and see what the result look like. So once again here, what do we have? We have the first number, let's say 3.5, 5.5. So here is the result. You could see the product printed as zeros. So what really happened? There is a small mistake here. We entered the first number, the second number, and I'm printing the product of C, but C has no value but only 0. As you can see, I initialized with a default value of 0. It will be already assigned 0.00. But you might run into such actually small little mistakes, dumb sometimes, but you have to be aware of the actual flow chart of your kind of code. So here we needed to do a multiplied by B. This is the line that we have missed. So we would have to run that again. Here is the result as expected. There's one more thing I would like to show you here. If I would have to add like type of numbers before this percent, for example, if we would have to write just .2 here, try to run that. What you could see here, only 2 digits are printed on the screen because I have identified here 2, and I'm asking actually the compiler to only print the first 2-digit rounded digit actually out of that product operation. Let's go and explore the next task. So our next task actually to find the ASCII value of a character entered by the user. Once again, let's create a new function here and let's call it the ASCII function. So what's the strategy one more time? It's the same exact one. So first of all, we have to define a character, let's say of type C, and then we actually want to prompt the user to enter that character. So as we are done, now we can use the scan a function. Now, after we finish what we want actually to do, we want to print the ASCII number of that character. First, let's say your character use specifier C, and the ASCII value, we're gonna now print a digit of that ASCII value. So you could see I am actually using the exact same identifiers, but the outcome would be quite a bit different. So let's try actually to run this function after, of course, we call it in the main function here. So here, say enter your character, let's say enter G capital, and see what the result looks like. Say you will see your character is G and the ASCII number of G is 71. Let's go ahead and review our next task. So our next task is say, well, let's try to find the size of integer, float, double, and characters. These are the data types that we discussed before. So in this case, in this function, just for education purpose, let's call it again a void function, and let's call size function. Let's define these types, integer of type A, and let's call character identifier C, and let's call float of F, and let's call one more type of double of D. And we'd like to know their size in the memory, how many bytes actually occupying. So if we have one print format here, we say the size of out the letter, whatever you're going to enter, is to use a specific type of specifier, which we have discussed in the previous slides. Let's use ZU type of specifier here, which is going to return the value of bytes. Okay, of course, we don't want to forget the new line here. And so we call the A. Same thing we're going to do with the C, and then with the F, and finally with the double. But to this end, we are not actually calling the size of bytes in this case. That's why we need to rely on a different function called the size of function. Now, this size of function, again, it's a built-in function which happens to be called from one of these include libraries or headers that we call the beginning of the application. So in this case, it's called the size of A. Same the size of C and F, and of course D. Here now we have an integer of 4 bytes as we discussed, the character of 1 byte, float of 4 bytes just like the integer, and finally the double is going to be of 8 bytes. Let's go and review the last task of this episode, and that is to swap numbers. So basically, as we have done previously, we need to create this function. Let's call it void again of type, and then let's call it number swap. Obviously, we need a variable of type integer. Let's call it A, the first number, and B. And then we need to swap these numbers. So whatever the value enter for A, B is going to take that value, and the value of B is going to be transferred back to A. So to do that, we need a kind of a temporary holder. So maybe we could actually create something called temporary, something like that. All right, so we have defined our variables. The next thing we need to do is to, of course, print and prompt for the user a digit. Of course, now we need to scan that and try to take the input from the user, which should be in the form of digit as expected, and then we're going to assign it to A. And we don't want to forget, of course, the ampersand. The same thing we're going to do for B. Now, as the operation has been done, now we need to do the swap. So basically what we could do, first of all, if we ask temp to hold temporarily the value of A, and then we could say, well, now A is equal to the value that B have. And finally, B will be equal to the value of temp, which actually previously was holding the value of A. And finally, we can just go ahead and print. Maybe we could do something more interesting and say after. And that's actually the same basic line. We could do it here before. So we don't want also forget calling the main function here, the number swap. Let's go ahead and run this, see the result. So as expected, we are prompted by entering the first number. Let's call it 3. And the second one, let's call it 8. And here we go. So we have before the value of A is 3 as entered, the value of B is 8. And then after, the value of A is going to be 8, and the value of B is going to be 3. Here is the swap happened. All right, so that was all for this episode. I look forward to see you on the next one. Stay well until then. Cheers.